Hi everyone, this is the last of our lectures on Chapter 9. We'll be covering chemical controls in this mini lecture. Chemical agents that are used in microbial control can occur in all three phases. They can occur in liquid, gaseous, or solid state. They can range from disinfectants to antiseptics to sterilants, things that can sterilize, and even preservatives. Some vocabulary words. Aqueous solutions are chemicals dissolved in pure water. Tinctures are chemicals dissolved in pure alcohol or water-alcohol mixtures. So how do we choose which antimicrobial chemical we want to use? What is looked for an effective chemical is one that has rapid action, even in low concentrations, solubility in water or alcohol, with long-term stability, that it's a stable molecule. We also want broad spectrum action without being toxic to humans or animals. And when we say broad spectrum, we mean that they are effective against a wide range of microbes. It's also great if they can penetrate inanimate surfaces, and that way they can stay and keep bacteria or other microbes away. And then also we want ones that do not become inactive when they come in contact with organic matter. So most of what we talk about when we talk about antimicrobial chemicals are germicides that would be looked at in a medical or dental setting and how effective they are. There's three levels. There's the high-level germicides, which can kill endospores and can be used as sterilants. So they can be considered a compound that could sterilize a setting. We also have intermediate level germicides. They'll kill fungal spores but not bacterial spores. They can also kill resistant pathogens and viruses. And then the third level is low level germicides, which eliminate only the vegetative bacteria or bacteria that are growing currently. And that's true about fungal cells too, only vegetative fungal cells. And lastly, they can control some viruses but not all. So factors that can affect germicidal activity of chemicals, there's many factors that come into play. Number one is the nature of the microorganisms being treated. What are we trying to treat or get rid of? The nature of the material being treated. Is this a countertop, a person's hand, food, things like that? Degree of contamination. How much of a microbe do we have on the surface or in the sample? The time of exposure, too, is something that affects how well the germicidal activity will work. How long is it being applied? And lastly, the strength of the chemical action of that germicide. These are all factors that affect the activity of a germicide. So when we're talking about the chemical strength of one of these chemicals, the things that you want to be thinking about are dilutions, and we did this in the lab, that a small volume of a liquid that is diluted into a larger volume of solvent, you probably saw in lab that the more concentrated were more likely to kill, and as we diluted that chemical further out, it was less effective. So dilutions are a key part of this. We look at that as parts per million. So for solutions, like chlorine would be one, those are ones that are very effective even at very diluted concentrations, so not very many parts per million. And then we talk about percentage solutions. This is how much solute is added to water by weight or volume. And this is often how you'll see these chemicals being shown. So the activity of these chemicals also is affected by the length of exposure. So most compounds need to have contact time for an adequate amount of time to allow that chemical to act on the microbe present. It also depends on what the surface or material is that's being treated. So if you have a smooth, solid object, it's much more easily disinfected than those with pores or pockets where sometimes bacteria can kind of hide out. Also, if you have a large amount of organic material, it can sometimes hinder the penetration of a germicidal chemical. And then lastly, before you use a germicide or a sterilant, you want to make sure that instruments or anything else are cleaned, adequately cleaned before they're treated. So when we're selecting them, we also look for things that are non-corrosive. They're not going to eat away at something or stain something. We also want ones that are sanitizing and deodorizing properties and that are affordable and are easy to acquire. And then lastly, no chemical can completely fulfill all of these requirements. There just are not one set one that we can say does all of these things. So there's a couple that do approach this ideal, but they're not perfect either. And then the last thing I wanted to show you, you'll need to look in your book because these are really small in the slides, but these are interesting to look at and see the wide range that we have of germicidal chemicals. This first picture is of the sterilizing agents. So these are the ones that are capable of killing bacterial spores. And this is in your book in chapter 9. And then the second half of this table are ones that are disinfecting only, so they don't have the capability to kill bacterial spores. I'm not going to probably test you on specifics for each of these chemicals, but it's nice to get a good idea of what the range is and the action, how that chemical groups, how it acts on a microbe to kill it. So hopefully this cleared up a little bit of this chapter, and if you have any questions, feel free to contact me.